data structures and algorithms. I know this is the most important and the toughest thing for a student who is preparing to crack companies like Google, Facebook, Amazon, Microsoft, etc. So to prepare for data structures and algorithms, there are hell lot of roadmaps available online. But if I recall my journey, even after watching a lot of roadmaps, and it took me so much of time to complete this data structures and algorithms. But don't worry, here in this video, I will be sharing an entire in-depth roadmap for data structure and algorithms. Even if you don't know anything about programming, instead of me explaining the roadmap to you, I have our Sidit sir who have been teaching from past 5 years, and lot of his students are now working in companies like Google, Amazon, Microsoft, Adobe, etc. And also he is the person who created the course curriculum structure for Scalar Academy and Scalar School of Technology. Also he was the head of instructors at Scalar Academy, and now he is the head of instructors at Scalar School of Technology. So who else could be the best person to explain you the roadmap of data structures and algorithms? So quickly, let's shift our cameras to Sidit sir. Hi sir.
Hey.
So many of our viewers have requested regarding the roadmap for data structure and algorithms. I remember my journey because when I get started with the data structure and algorithms, I was not able to be consistent in my journey. So I don't want that to happen with our viewers, and I want an in-depth roadmap that has to be discussed with our viewers. So before getting into the roadmap of data structure and algorithms, say why they should do that, because so many students, if they don't have any motivation to do that, what is the end result, they won't get started with that. So over to you, sir.
Got it. So DSA, so you can see that it has data structures and algorithm. Data structures are a way of managing and storing data in your memory so that it can be manipulated very efficiently. On the other hand, algorithms are nothing but set of instructions that you are going to follow in order to solve a program. So data structures and algorithms are going to go hand in hand, because in computer science, whenever you are solving a problem, you need the correct set of instructions which you need to provide to the computer, and to run those instructions optimally, you also need to arrange your data in the most optimal way. So data structure is the arranging data part, and algorithm is nothing but those set of instructions. Now data structures and algorithms are everywhere, from databases to operating systems, from search engines to social media networks. For example, the back button in your browser, the back and forward button in your browser, that is based on a data structure called stack. The playlist in your Spotify, that is based on a data structure called linked list. Google Map, any social media network like Facebook or Instagram, these are based on a data structure called graph. And that is the reason why companies like Google, Facebook, Amazon and many others are going to test your problem solving skills using data structures and algorithm problems.
So sir, whatever until now have been discussed, they might have understood that okay, data structure and algorithms are really important for cracking companies like this and this. But now they don't know the concepts which you have mentioned, like stacks, linked list, graphs and everything. So for them, if you can give what are the next steps, step-by-step process, how to start from fundamentals, so that they can master in data structure and algorithms and not do mistake like me of getting lost in the learning journey. So let's start with giving them a roadmap.
Sure. So should we move to the whiteboard?
Sure, sir. Sure. Let's.
Okay, so you cannot directly start learning data structures and algorithms. Right? Data structures and algorithms are going to be your tools to write efficient code. But before that, you need to learn how to write the code. So before you start learning data structures and algorithms, you need to be good with at least one of the programming languages. Most preferably, it should be C, C++, Java or Python, or you can pick any other language of your choice as well. If you're starting with C, it is possible that when you start learning more complicated topics, you may have to switch to C++ or Java. So keep that in mind while starting with C. Now, in any of the language, there are a lot of things to learn. So you don't need to learn every single thing, every single feature which is present in the language before starting with DSA. You just need to go through these things. You need to know how to take basic input and output. You need to know the conditional statements like if and else or switch cases or both of them. You need to know how to do something repeatedly using loops. So there are for loops, there are while loops. You need to be comfortable with them. Then you need to be good with the primitive data types provided in your language. You need to know what are the limits of various data types. For example, if you are dealing with small numbers and you are using Java, you would probably go with integer data type. But if you are using large numbers, then integer data type might not be sufficient to store those large numbers. So you might have to go with long data type. So those primitive data types should be clear. Then you should also know what are functions and how to write functions in your language. Functions may not be very important if you're a beginner in your initial journey, but later on functions are going to be the most important thing. And when we'll learn concepts, harder concepts like recursion, then those concepts will be completely based on functions. So this much of language construct should be sufficient. Other than this, what you can do is you can learn some basic math concept like the mod operator, which gives you the remainder, and you can see basic applications of the mod operator. For example, how to extract all the digits of a number or how to reverse a number. So all those things you can do if you know how to use loops and how to use the mod operator. Talking about loops, you should not just be comfortable with a single loop, you should also be comfortable with nested loops. And nested loops means loop inside a loop. So for practicing those type of questions, you can do something known as pattern printing. You can print various different type of patterns. You can find multiple such questions online, and printing these patterns will give you a really good hold on loops, which will become crucial in this data structures and algorithm learning journey. So once you are done with all these basic language constructs, once you have a good hold on this, once you know how to read, write and understand code in any of these languages, then you can start your DSA journey by learning the most fundamental and most widely used data structures, which is arrays. And in arrays, you will find all type of problems ranging from very easy to very, very hard. So make sure that you are not picking up the most hard problems in the start. You should be starting with the easiest problem first. So in the easiest or the most basic operations that you can perform on an array, you can explore how to search a number in an array, how to do basic manipulative operations on an array like rotating it, reversing it, or finding the minimum and maximum of the array. After doing this, you can move to another concept of finding the time and space complexity of a program. So whenever you are implementing a solution, whenever you are writing a code to solve a problem, there could be multiple different type of solutions which are possible. Which is the best possible solution? What is the measure of that? For that, you need to learn time and space complexity. And once you know what is the time and space complexity and how to calculate it for any given program, you can move to much more complicated operations like sorting an array. So when it comes to sorting, there are again multiple different ways through which you can sort an array. Multiple different algorithms are there. But in your initial part of the journey, you should explore bubble sort, insertion sort and selection sort. There are other algorithms as well, which probably you can explore later on in this journey. So after sorting, you can explore how to find an element in a sorted array, which is binary search. Because finding something in a sorted array, sorted means where data is arranged in a specific order, is going to be much more optimal as compared to finding things in an unsorted array. So after doing this, you can also explore the algorithm called binary search. Once this is done, then you can also explore some problems on 2D arrays. So 2D arrays again are very, very widely used. One very good example of 2D array in practice are images. So if you have used any image editing software, you are actually using a 2D array. Images in the memory are stored as a 2D array. So in 2D arrays, you can explore how to iterate over it row wise, column wise or diagonally, how to rotate a 2D array or how to take a transpose of the 2D array or the matrix that you have. This much should be sufficient for you to move on to the next set of data structures. Now linked lists look very similar to arrays because they are also a linear data structure similar to arrays. However, they are very different also. They store the data in a very different way as compared to the arrays, and that is why there are some pros and cons of using linked lists and arrays. So just make sure that you understand how linked lists are stored inside the memory, and then understand how to create a linked list, how to insert nodes in a linked list, how to search some data in a linked list. Then you can move to little more complicated operations like reversing a linked list or finding the midpoint of a linked list. Now just a reminder that right now we are talking about this journey for beginners. So there are a lot of other complicated things which we have left out in the arrays, and there could be a lot of complicated things in linked lists as well. For example, in arrays you may get questions which need little bit of pre-processing before you solve the question. So you might be asked to find range sum queries, for which you will have to make use of something called as a prefix sum. There are problems which will have solutions using two pointers. There are problems which will have solutions using something known as a sliding window. Similarly, in linked list you may have a doubly linked list, you may have a circular linked list, you might be asked to remove a cycle from a linked list. But all these are not to be done right now. Just get yourself familiarized with all these data structures before moving into harder or complicated questions. So just do these things, and then you can move on to the next set of data structures, which are stacks and queues. So stacks are nothing but any data structure which provides you last in first out type of access. Last in first out means, for example, if you have a stack of books or if you have a stack of plates, you cannot fetch a plate from somewhere in between, otherwise all the plates will fall down. So you'll have to pick the plate from the top. You can only put the plate on the top. So any extraction is happening from the top, and any insertion is also happening on the top. On contrary to that, you have something known as queues. Queues means first in, first out. So this is a FIFO data structure where insertions are happening on one end and removal is going to happen from the other end, similar to a queue of people standing in front of an ATM, right? So stacks and queues are abstract data types. What are abstract data types? Abstract data types are nothing but type of data structures which are defined by their functionalities rather than how they are storing the data internally. So arrays and linked lists, they both differ from each other based on how they are managing and storing data internally in the memory. But stacks and queues, they don't care about that. You can implement a stack using arrays, or you can implement a stack using linked list. The only thing that is important in a stack is push and pop operation. Whether you are implementing it using arrays or linked list, these two operations should be supported. Similarly, in queues, add and poll operation should be supported. So stack and queues both are very widely used in solving a variety of problems. For example, if you are implementing an application which requires undo and redo feature, so whenever you press Ctrl Z, you might have observed that Ctrl Z will undo the most recently done feature. So if you make a change and you do undo, it is going to revert back to the most recently done change. Stacks and queues, both of them have a variety of applications. For example, the undo and redo feature that you use in Google Doc or any other application is built using stack because it is last in, first out. If you are using a printer and you are doing multiple print commands, then that printer maintains a queue of the documents which it has to print using the queue data structures. So these are just examples. A lot of other applications are there which are going to use stacks and queues. So two things that you need to do while learning stacks and queues. First, implement a stack using arrays and linked list both. Implement queues using arrays and linked list both. And you should also try to implement stacks using queues and queues using stacks. And when we do this, when you are trying to implement stacks using queues and queues using stacks, it would be very important to see how you can optimize your time complexity. So after doing arrays, 2D arrays, stacks, queues, linked list, now you can move to the next set of data structures, which are sets and maps, hash sets and hash maps. And these are the data structures which are going to take your problem solving game to the next level. Why? Because these are the most optimal data structures if you want to search a data in a data set. So whenever the use case is about searching a data, counting the frequency, checking whether something is present in the data set or not, most of the times we are going to make use of sets and maps because they are the most efficient data structure for that. As a beginner, you don't need to really dive deeper into how sets and maps work internally. However, that would be important when you move to the advanced concepts. But as a beginner, you can treat them as a black box, learn their functionalities and start using them to solve the problem. So all the data structures which we have seen as of now, including arrays, linked lists, stacks, queues, all of these are kind of linear data structures. Linear data structure means the way you arrange the data or the way you access the data, that is kind of linear in nature. That is not hierarchical. However, in a lot of use cases, you would want to store data which is present in a hierarchy. For example, your file system, right? If you're using Windows, then you might be having a My Computer, inside which you would have multiple different drives. Inside those drives, you will have different folders and then more folders or files. So that is a hierarchy of folders and files. Similarly, if you want to store data of roles in a company, then you will be having a CEO, and then you will have a CTO or COO or CMO reporting to the CEO, and then you will have the engineering managers reporting to the CTO, then you will have SD2, SD3 reporting to engineering managers, and so on. So that is a hierarchy. Now storing and iterating over this hierarchical data is not very optimal using these linear data structures. So for these type of operations and for making searching even more optimal, we have something known as trees. Trees are hierarchical data structure, and when we say trees, most of the times we will be talking about a specific type of tree which is called binary tree. Trees are going to be extremely hard. Even the simplest operation on trees, like printing the values of all the nodes, is going to be extremely hard to implement if you do not know something known as recursion. So before you move on to hierarchical data structures like trees, it is advisable that now you take a break from data structures and you explore a way of writing code using recursion. So recursion is not any algorithm, it is not a data structure, it is just a way of writing the code. In layman's term, recursion is nothing but when a function calls itself. For example, you will be writing code to calculate factorial while learning loops. You will be writing code to find the summation of first and natural numbers using loops. The same thing can be perceived like this as well. So we can say factorial of n is nothing but n into factorial of n minus 1. So we have broken down that function in terms of itself using a smaller input size. Similarly, summation of first and natural numbers is nothing but n plus summation of first n minus 1 natural numbers. This is recursion. Another very widely used example of recursion is the Fibonacci series, the well-known Fibonacci series that gives us the golden ratio, where any nth term of the Fibonacci series is equals to the sum of previous two terms of the same series. So again, you can see that the function is using itself to calculate the value. This is recursion. This recursion will be required to solve tree problems very easily. If you know recursion, tree becomes a cakewalk for you. If you don't know recursion, you will have to write hundreds of lines of code to solve the simplest problems of tree. So this is the point where a lot of students get stuck. So the simple reason for that is it is not very easy to visualize recursion for larger inputs. So when you are having large inputs and when you are having multiple recursive calls inside a function, it becomes really hard to understand how that recursion is functioning internally and to visualize how the data is being processed internally. So if you want to get a good hold on recursion, you should start with writing the exact same codes which you have written in that basic while you were doing the basic questions using recursion. For example, you have already done how to reverse an array. Now write the same thing using recursion. You already know how to do binary search over a sorted array. Do the exact same thing using recursion. You already know how to reverse a linked list. You can do the same thing using recursion. With this, now you can also expand your knowledge of sorting algorithms by implementing two of the most optimal sorting algorithms, quicksort and merge sort. And their implementation is also done very easily using recursion. So if you know recursion, you can not only solve tree problems very easily, but you can also implement these two sorting algorithms. So once you have a good hold on recursion, then you can learn trees, and not just trees, you can explore various different type of trees. For example, you have binary search trees, you have balanced binary search trees, you have heaps and priority queues, which are also a specific type of tree. You have tries using which you can optimize string search. And then you can move on to further complicated data structures like graphs. However, as a beginner, having a good hold on arrays, 2D arrays, linked lists, stacks, queues, sets and maps, and basic recursion should be sufficient. We may talk about further advanced topics in the next video.
Yes, sir. Thank you so much. And for our viewers, if you found this video really helpful, then or you have any doubts, because it was like there are so many things that are not even discussed in this video. So if you have anything or any doubts or any request, please do comment in the comment section. So based on the response and the love that you show on this video, we will be making the next part of this video so soon. So please make sure that you share this video with all your friends. And that's all for this video. Thanks for watching, and thank you so much, sir.